What's up? What is up, chumps? Alright, we are back for some more Radix learning. And in this section, I guess this time, the two things I have, or maybe three if we can get to three, I want to learn about the Radix gateway, the wallet connector API, and how the fetch I write tests. So just kind of those three things should complete the circle for me as far as my ability to develop Radix smart contracts. Just specifically, I learned Rust a little while back. I learned Scripto and the different principles that govern how Scripto works last week. And once I'm able to write the language, then it becomes a question of, okay, how do I deploy? Or first off, how do I test? How do I test code that I write? Because I need to ensure that it works in the way that I intend it to work, and that it can't be broken by different things that people can do. So I gotta be able to write tests. I need to be able to deploy my smart contract. I need to be able to interact with my smart contract, which involves being able to sign transactions with a wallet. I suppose you could say a fourth piece of that might be like, how do I read information from the blockchain? So I'm going to add that actually. How to read data from the blockchain. I guess in this case it's not a blockchain, a ledger. There we go. So I've got my details in place. I kind of have a roadmap for myself, for my own learning, and we're on the final step. So after this, I would feel pretty confident learning, or starting to write smart contracts. Because I could make sure, if you think of it as a triangle, you have a DApp. DApp interacts with Ledger. Ledger and DApp also interacts with Wallet. So I'm querying information from the Ledger for my DApp. I'm signing transactions with my Wallet from my DApp, and so we kind of have this triangle. There might be some back-end services that are Web 2 side of things, but that's the basic structure of a DApp, of, I would say, almost every DApp. And whether or not the wallet is the one that sends the transaction to the ledger, or the DApp sends the transaction to the ledger, I don't really care. But there's still that triangle. There's still three distinct entities that I, as a developer, need to be aware of when I'm building DApps. My DApp, the user's wallet that I connect to, and the ledger. So in this next hour, those connections and the flow of information between each of those three pieces is kind of what I'm going to be tackling. So first things first, we're going to whip out the interwebs, and it's going to be good. Let's see, I'm just going to pull up a browser so you can't see what I previously had going on, but let's see, Radix docs. There we go. Alright, so first thing we want to learn about is our Radix gateway, which is right there. Perfect. Overview. Jumping right in. Perform the role of validator, act as a full node, and index the ledger. Okay, index the ledger. Alright. The node exposes the system API for monitoring and the core API for reading low-level ledger state and submitting transactions. That's already good. That kind of already answers, how do I read data from the ledger, I suppose. And I guess would be if I would need to query or contact a full node to get information. The network gateway acts as a point of entry into the network for most clients, serving requests from wallets and explorers about the ledger state. Okay. And facilitating easy transaction building and submission onto the network. The network gateway sits in front of one or more full nodes and makes use of their core APIs to interface with the network. Okay, sounds like the network gateway is the thing I'm going to be dealing with. This is supported by a Grafana dashboard and monitoring stack. What's that? Grafana. I don't know what Grafana. Prometheus. A service. Okay. Course 10K. Okay, it looks like it's okay, observability. It's a new one. I don't know. Observability stack. Okay, so basically, analytics. Sounds like analytics. It is Prometheus. Power your metrics and alerting with the leading open source monitoring solution. Okay, so sounds like Grafana is for analytics. Prometheus is for gathering data, like actually monitoring things and getting information out of that. Okay, interesting. Yep, okay, great. I should have just looked at this nice little graph. So we got Radix node, gateway API, gateway aggregator, goes into Prometheus, Prometheus monitors things, Grafana takes everything that's been monitored and displays it to the user. So that makes perfect sense. All right, cool. Let's go back to our overview. Wait, I'll just keep that open. Before I go on, actually, I need to take some notes. Time to take some notes. Some notes. Should never do things without taking nice notes. Alright. Close others. Okay, so this is Radix DLT. Maybe I can probably dive a little bit deeper, maybe go to the Radix engine, but for now I'm just going to throw it in here. Yeah. Where should I put this? Prometheus and Grafana. This is Obsidian, by the way, if any of you know what that is or don't know what that is. Well, it's like my second brain, basically, to Prometheus to monitor the nodes, and Grafana to display information from Prometheus. Dashboard monitoring stack. And I'm gonna just add this nice link in there. Read now. Boom. Okay, taking our notes. Okay, back to our overview. Alright, Radix node. Let's look up what a Radix node is first. Everything just changed. Okay, I thought, let's see. So, I mean, we have node over here. Okay, we're in network. Alright, cool. Our introduction. State observes the status of the network. Can also be thought of as a kind of wallet that is connected directly to the network with the node's own account available for programmatic control. Further, can be configured to store the ledger transaction stream, which can be exposed by the core API. Alright, we're going to look you up later. Validator node starts life as a full node, but has also registered itself to the network as a validator by submitting a special transaction from its account. Registration means that it may now accept XRD token state and potentially be included in the validator set of 100 nodes that conduct network consensus. Okay, interesting. So I knew that Radix had a cap on the number of nodes that could exist or like work for network consensus, but I didn't know it was only 100 nodes. So, I mean, that seems like a low number to me. I'll be 100% honest. I would love some feedback on that. I'm going to write that down as a question. Why is the validator node set limited to 100? All right. Okay. So I don't care about running a node. I will be completely honest. So it's just important to know this stuff. Let's hop over to the core API. This is how I interact with crap. Core API docs on Redocly. All right. The core API is separated into 3. So we got data. Okay, good. Construction. This is you construct and submit a transaction. Key APIs use the key is managed by the node to sign transactions. That's a weird one. So nodes sign transactions? Well, I guess they do, but I don't know why I would need that API exposed to me. Ledger analytics providers or hosted ledger data dashboards or detailed ledger data. Use of JSON-based RPC protocol on top of HTTP. Okay, JSON RPC makes sense. It's universal language to express asset movement for reading and writing. Makes sense. There are a few notable exceptions to note. We are noting our notable exceptions. Fetching of ledger data is through a transaction stream rather than a block stream. Well, I mean, that makes sense. We don't have blocks. So that's, yeah. Use of entity identifier rather than account identifier. That makes sense too. Radix is based around the idea of blueprints and components constructed from the blueprint. So we don't have accounts per se, we have entities. Maybe an entity would be a component. Operation group rather than related operations. Okay. Construction endpoints perform a coin selection on behalf of the caller. It'll support high frequency transactions from a single account. This will be addressed in future updates. Okay. Construction endpoints are online rather than offline is required by Rosetta. Okay. Enter fully. Okay. It's been enabled with configuration API sign enable true. This is a potentially dangerous endpoint of accessible publicly, so it must be enabled manually. Okay. Data flow API. Yeah, okay. The data API can be used to synchronize a full or partial view of the ledger, transaction by transaction. It's a long-running process and the database on which they would like to maintain and store their own state. Okay, that makes sense. So basically we have a Web 2 service or some service that's designed to store the state of the network and keep it in sync. So we load local network. We get the local network. So this is their Web 2 service, Web 3 service, something other than just a Radix core API. Okay. Verify that the networks between our local database and the node are the same. Okay, network configuration. Otherwise, there must be a misconfiguration somewhere. Oh, so basically they're saying you can host your own database, and maybe they've provided a way for you to just host data for yourself, serve your own data, and just keep it in sync with the Radix core API. That would be nice. That would be really, really nice. So if I could just, I guess, spin up my own node. It's detached from everything, but I just keep it up to date based on transactions that occur on the Radix mainnet that I care about. That way I can just immediately request information from that, and I pay for that service, all that good stuff. So I'm kind of separate from everyone else, and people can't harass me, molest me, denial of service, attack me, because I block access to my own database. Okay. Our local database and the node are the same. So I don't really get that step 100%, but I mean, okay. Verify that the node is ahead of the local database. Otherwise, you must wait until the node synchronizes to the latest state version. This may occur if the node's database had to be wiped and restarted for some reason. Okay, yeah, that makes sense. Okay. If a local state identifier does not yet exist, for example, when starting a fresh light client, you can start with the pre-Genesis state identifier value. Oh, well, okay. Non-transactions every 5 seconds. Atomically store the latest state identifier and state updates for each transaction in the transaction list to the client database. Yeah, so basically they're walking you through using the core API to create your own database and keep it up to date. Cool. So we're going to take a look at construction API flow. This is something I'm curious about this. How does this work? Construction API can be used to construct and submit transactions to the network. API caller and a separate private key holder for signing transactions, though they can exist in the same process. Okay, so they've specifically said we're going to separate the person sending in the transaction from the private key that is signing the transaction, which I guess kind of makes sense because that enables you to have both, let's say, a flow of, custodial, for example, is a great example of this, where this would be very valuable and useful. It's custodial. Custodial, they hold your private key, they can sign transactions on your behalf, all that good stuff, So that's actually really, really nice. It also means that they don't have to store all of their tokens on the exact same account, though there's no reason for them not to, so, why would they not? Okay, we assume there is an API caller and a separate private key holder for signing transactions. Verify that the networks you are expecting to work with. Okay, so this verify network thing, I'm just going to assume that if someone is trying to spoof us in some way and make us communicate with something that we're not supposed to communicate, we shouldn't do it, right? Okay. Get required entity identifiers for transaction. I guess we send in our public key, we get the entity identifiers. I assume we're going to learn about that a bit later. I don't know what an entity identifier is, but I suspect it's like the outputs of each different transaction. That would be my best bet. Begin the construction of your transaction by specifying your intent through operations and operation groups. So this would be like our transaction manifest. That's what we learned about last time. So the transaction manifest is probably compiled into a series of operations or operation groups that happen throughout the transaction. And that would be the caller constructing the manifest. Okay. So we parse the transaction, parse the return transaction, which should include additional information such as fees and substate information. Verifies that it matches the original intent. Okay, so basically we're validating. Perhaps this is like a dry run or simulated execution of the event, which would be really, really nice if that's something we could do. So we could just see what would happen if we were to execute it. This is something that exists on Cadena. You can simulate a transaction before you actually commit it, which allows you to see, what's going to happen, or like ensure your expected output before you hit commit. Now, obviously, the actual commit, there could be something different. So let's say there's like a high amount of volume occurring on a DEX, and you just wanted to make sure that you would get your proper amount. Like, it's still not going to work entirely for that case. Like the actual live information will likely change before the data is committed, but having that simulate is still super nice. So I'm going to assume that that's what this is talking about, is that you're able to construct and, I guess, test. They're calling it parse, so maybe it's doing like a dry run, I'm not sure. But it would make sense if it does. Get the hash signed by the private key holder. Yeah, so we sign the hash with the private key holder. My assumption, honestly, would be that, like, let's say we're going to learn about the wallet connector API. My assumption would be that the caller and the private key holder in that context are the same thing. The caller would be my wallet. And, well, I guess maybe you wouldn't. Thinking of that triangle, like the D app would be the caller, private key holder would be the wallet, and I request a signature from the wallet, and then I send that signature off to Radix Core API. So I could see the wallet being the thing that submits the transaction for me, just because I know Radix is pushing really, really hard on a really, really nice user experience. So I could see them just doing all of that for me. But they've also set it up so you can separate the two, which makes sense. Totally understandable. You want that. Abstraction is a good thing. Okay, get the hash signed by the private key holder. Yep, so we sign it. Boom. That makes total sense. We construct the final signed transaction. Note that this transaction will not be broadcasted yet. So what does finalize do? I guess we submit the signed transaction with our transaction modifier identifier. Yeah, so the Radix core API, it selects UTXOs on behalf of the caller. This is the unfortunate side effect of not being able to support high-frequency transactions from a single account due to UTXO conflicts. This will be addressed in a future release. Okay, so that provides some additional clarity on what was set up above. Whoa, what just happened? What's going on? Just want to scroll down. Okay. Yeah, so that makes sense. Like, basically because it's saying, what that's saying is because of the UTXO model, the issue that you have is that you must wait until, like, let's say the high frequency transactions from a single account can't occur, because in order to execute high frequency transactions from a single account, you need to have a reference to the previous transactions. Unspent transaction output. When you're using unspent transaction output, you're referencing previous transactions in the new transaction you just did, which means that you must await the completion of the first transaction before you can execute the next one. Unless you have a series of other transactions you could reference that would allow you to still accomplish the transaction that you want to do. But either way, high frequency transactions, like let's say you're doing like 50 every second, that wouldn't work in UTXO, because you'd have to wait, let's say, maybe 3 seconds for each of those transactions to complete, and they would each have to reference the previous one. So, makes sense. I understand it. And hopefully my description made sense to you as well. Alright, entities. Entities represent something that can hold resource balances, and data objects. For example, public key account is an entity which can hold token balances on behalf of a private key holder. Yeah, okay, so this is what I thought. An entity is a component. And that makes sense. That makes perfect sense. Operation is an update which occurs on an entity. A data operation, which is a data object update on an entity. Yep, so cool. Structure. There are different types of entities on Radix, each of which contain certain resources and data objects. Okay, so before I keep going, I'm just going to take some notes on all of this good stuff. So, just Radix DLT in general. It's got the we got the data API flow used to sync partial or full view of ledger transaction by transaction. This doesn't need that flow in there. And submit a transaction to the network. Makes it easy to get previous, we'll call them entities. Outputs, use them in the transaction. Right, the last step is entity. Represents something that can hold resource balances and data objects. Alright, okay. Structure, addressing. Wow, this is really, really long. Ooh. Wait, okay. Alright, so we're going to get into some things that maybe I don't really want to get into. This is our Radix gateway, so I mean, how much of this do I really care about? I'm not 100% sure, but these are some great docs. Okay. So there are different types of entities in Radix, each of which can contain certain resources. Okay. Account, validator, token, system. data such as current epoch and round. Okay. So the tokens which have been staked to this validator. Okay, I am curious what so we have our DX1 account. So I guess this isn't components, they only have these 4 things, but I feel like maybe this information is out of date. Right, I'm gonna ask that as a question. Is the PI docs up to date? Alright. So we made some pretty good progress in 26 minutes. I'd say we have a pretty good comprehension of the Radix gateway. I don't know what just happened. Whoa. Come on, buddy. My laptop does not like streaming and doing all these things at the same time. Okay. So back 32 encoded. What do you mean? Oh. For native V016 in this output. So what does that even mean? What is it? Checksum base 32 format. Back 32. Standard for native segregated witness output addresses using it. Segwit, segregated witness. Truncated double SHA checksum. They're part of the original software and their scope extended to bit 13. Okay. I know I'm probably diving way deeper than anybody wants to know, but I appreciate understanding this stuff. It really lets me develop better. Also, so that if I run into like a back32 address, I'm like, I understand what that is. I know what that is. And it's not just like, what the fetch is that? Back32 string is at most 90 characters long and consists of the human readable part, type of data, or anything else that is relevant to the header. 1 to 83 US ASCII characters. Okay. The separator, which is always 1. Okay. The data part, which is at least 6 characters long and only consists of alphanumeric characters, including I, B, I, and O. Okay. Interesting. Valid strings must pass the criteria, so I guess we take the human readable part and well, they called this the data part. Is the data part the checksum? Nope, it's not. They're different. Okay. It's a list of integers representing the characters after conversion using the table above. Okay. So they have they have their own encoding, all that good stuff. Man, I've written so many mathematical libraries, I'm just tired of it. I don't want to write another one for this, but I'll probably end up doing it for something like C# so I can use it in games. Oh, okay, alright. Redockley, where'd you go? Oh, are you here? There we go. And we're back. Further restrictions on which Okay. Mainnet address of the native token, XRD, is XRD RR1, the nice separator. Then you have the data afterwards. Encodes the token's unique Radix engine address on ledger. This Radix engine address is hex 01 for for XRD, and presently hex 03, I guess ORed with the double SHA of for user created tokens. That's the byte concatenation operator. What in the flip heck? Okay, yeah. So, okay. Byte concatenation operator. Okay. We are learning. We probably, hopefully, don't need to care about any of this, but you never know. I actually think, like, right now in its state, I would suspect that we probably need to know at least a little bit about this. Okay. So then we can track transactions. Transaction accumulator along with, okay, the Radix network has no concept of blocks. Instead, transactions are managed in a flat ordered list. Interesting. Hash chain is formed from these transactions called a transaction accumulator. A transaction accumulator represents a point in time of the ledger with a valid state. Okay. Which occurred up to state version. Is an atomic state update to the ledger consisting of one or more operation groups, each of which consists of one or more operations. Got it. Okay. Committed transaction has additional information such as the state identifier, which results after committing the transaction. A transaction was committed on ledger. So has the identifier, excuse me, the committed state identifier, the metadata. Look, we got all of our groups. Interesting. Amount, substate. Yes, we have references to the substate identifier. Oh, substate operation. I wonder what that is. Honestly, the first thing that you always need to do when you're working with a new system, understand the fetch data. Which is why I was okay going over and looking at the BEC32 encoding that they have to represent addresses. So, in this case, like, I don't know what shutdown means, but my guess is that it means that we consume the substate, whatever that may be. So, we have an entity identifier. Yes, we have our address, we have RDX1, followed by all of our good stuff. And we have a type, and it's a resource. We have an amount. We identify the resource. We're subtracting 24 lots of stuff from it. Then we are adding all of this back to it. I'm assuming this is like the gas fee. And maybe this RDX1 is just XRD, the XRD token. I could see that being the case. Then we have an action, and it's amount. Oh, we burn the tokens. Ooh, okay. So this, I assume that this would be like our transaction manifest. Like these operation groups built from transaction manifest. Which is interesting. I mean, I like that. Personally, I really like that. Because it's just like, it's like, I just define in my JSON precisely what I'm going to do. And it's able to do it, which, that's super nice. So this operation group has two operations. Operation 1, and I assume they go from like left to right, top to bottom. So like transaction manifest, top to bottom, we're just looking at blocks of things that are occurring, and I assume that each one of those would just be an operation. Perhaps one of them could be an operation group, for example. So if I'm like doing like transferring from a DEX or something like that, it'd be transfer in, transfer out. Maybe. That's probably too mundane of an example, but that's what I'm seeing. So that's really, really nice. Similar to the Rosetta API, both reading and writing ledger use the same address on operation objects, which operates on a single entity. Okay, right. Any state changes, which consists of two accounts. This requires at least two operations, one which debits the sender and one which credits the sender. Okay, so a DEX swap would actually be very accurate here. So every single operation, like the operation to remove tokens from the account, like I should say, I guess that would break down to potentially 4 operations. So operation 1 would withdraw funds from the account, like my account. Operation 2 would put the funds into the DEX. Operation 3 would take the appropriate amount of funds out of the DEX. Operation 4 would put them into my account. So 4 distinct operations there. Interesting. Okay. Yeah, so you can just store them in a list. And the transaction manifest likely just breaks down to this list. So metadata here, I don't know if that feeds into the linked via operation groups. Okay, so you would put like debit and credit inside of an operation group. Describes the entity which have arbitrary balance and data. We got our amounts, assigned amount, of a resource identifiers. Yeah, those are important. Data updates. Okay, data update is the creation of or destruction of a data object. At any given time, an address will have up to 1 created but not deleted data object of each type. Of each type of what? Type round data. Okay, okay. I don't fully understand that piece, but that's okay. It's a bit too vague. So we can get transactions. Oh, say a Java API maybe. Might be out of date. Not sure. Now they're just getting into code. Okay, so alright, so that is our Radix gateway, and I'm gonna call that good. I feel like I have a pretty good comprehension of the data structures that go into it, comprehension of the operations, assuming obviously that this is up to date. I don't know if it is, but I can't imagine that they changed it a great deal. I suspect that the same principles that make it function now are still something that govern it today, even if it is out of date. So, good thing about principles, they don't generally change. Implementation may differ, but principles generally don't. So I suspect that the data structure, like that we saw down here, might be different, but this flow, I'm not sure if they would have gotten rid of that, because from my perspective, this is a great flow. Absolutely phenomenal. And just a great example of that, like triangle, right? You've got the ingester, Mr. D app. You've got the wallet. Well, I guess that's not it. Construction flow. There we go. We've got our caller, D app, wallet, private key holder, Radix Core API, ledger. Boom. Our triangle. They've got it right here. So I'm happy with this. Data API, identity mempool, transactions. You know, I could read into this if I really, really wanted to. Oh, these are just the actual endpoints. Ooh, okay. So I can get mempool transactions, I can get committed transactions. Okay. Something I guess I would probably need to understand a bit better is the state identifier. Because their description of kind of how all of that works is like transactions are just put into a hash list. That seems a little weird to me, to be honest. Especially given the fact that they say that they can shard their state. So I'm not sure that they've ended up like stayed with that particular data structure, because it doesn't serve itself well, from what I can see, to like if I'm doing multiple transactions at the same time, it's like that list right there gets locked up, and essentially you have the same problem as a blockchain. So I don't think that is how they did it. I do think that's different. Okay, so now we need to go and take a look at. Okay, so that was our Radix node, that was a network gateway. I want to look at the wallet connector API. Where would you be? Wallet connector. Radix desktop wallet. allows anyone to hold, manage, and stake XRD tokens, as well as other tokens created by developers, from which to delegate the stake of their own tokens to their node. Desktop wallet to connect to their gateway API to test that their API is working correctly. Okay, so Explorer can be used to... Ooh, Radix Explorer, what do we got? I love looking at data. Give it to me. Do I have to search? Transaction ID, validator ID, maybe that won't work. I'm using a lot of bandwidth on this. Okay. Owner stake, fee percent, recent uptime, address. Okay, so this is where you stake. They got their website. Cool. Not accepting stake. Okay. Wow, these guys have 0.5% uptime, 2% uptime. That's horrible. What? We still have 1.6% of tokens that are currently staked. That's interesting. Wonder where that would be. So you got lots of people with just a 100 stake. Huh. Interesting. Okay, that wasn't super important, but let's see. Wallet connector API. Where did I learn about that? Learn radixdlt.com. Set up your wallet. Okay, I feel like I would find this in like the docs. So Babylon specific site, there we go. Radix node and gateway, Radix APIs, front end tools, Radix DApp toolkit. This is probably a wallet SDK. The wallet SDK and gateway SDK along with the framework agnostic connect button. Okay. Together they make it easy for developers to connect users and their Radix wallet to their dApps. Okay. So I guess from their perspective, so they have separated the wallet. It doesn't look like the transaction. Oh, let's restart. It does not look like the wallet sends the transaction to the gateway SDK, given the fact that the gateway SDK is right here. So wallet SDK. For more information about building a DApp front-end website, TypeScript developer SDK. Alright. We are making progress. Getting started. Okay. So we install it. Makes sense. Wallet SDK. Boom. DApp definition address. Okay. Network ID. No idea what that is. Alright. Specifies the DApp that is interacted with the wallet, used in the DApp verification process on the wallet side. Okay, so do you have to register a DApp then? I'm learning about that. Optional network ID specifies which network to use. Defaults to mainnet. O1. Okay. Log level. Okay, I like that. Logs. Okay, get wallet data. Login with challenge, login without challenge, use a persona. one-time accounts without proof of ownership. Because basically just give me your accounts, but don't prove that you own them. One-time persona data, ongoing persona data, okay. There are two types of data requests, one-time and ongoing. Always result in Radix wallet asking for the user's permission to share the data with the DApp. Ongoing data requests will only result in Radix wallet asking for the user's permission the first time. If accepted, the Radix wallet will automatically respond to future data requests of this type with the current data. User's permissions. Okay, makes sense. Makes perfect sense. Login request, which will return the identity address for the user's chosen persona, which can be used for further requests. Okay, so they accept a login without a challenge then. Login without challenge. Requests, request builder, login without challenge. Request item, ongoing accounts without proof of ownership. Okay, so interesting. Okay. Notice that the request item use persona identity address needs to contain the stored identity address. Well, is that below? There it is. Okay. Request item. Is this meant to be there? Can I log in and get the accounts at the same time? It would make sense that I can. But alright, so we got our identity address, we got the list of accounts. Without proof of ownership. Dang it, excuse me. Okay. One-time accounts with proof of ownership. Without proof of ownership. What does the 3 mean? What's 3? Account with proof of ownership. Okay. Am I getting 3 accounts? I don't know what the 3 means. But I mean, this looks relatively simple. I feel like they've done a great job. I was reading through it. Get list of persona data. Failed value field. Given name, family name, email address, phone number. One-time persona data. Given name, email address. So I can request different data types. Okay. Ongoing persona data. Reset request to ask the user to provide new values for ongoing accounts and or persona data. So we can reset accounts and persona data. Okay. Since the user experience in the Radix wallet is able to without any server backend, you may simply want to request such a login from the user's wallet so the wallet keeps track of data sharing preferences for your DApp and they don't have to reselect that data each time they connect. Whew. If your DApp does have a user server backend, a persona-based login provides strong proof user identity. Once your DApp is given identity address, it may be used for future requests for the data that the user has given ongoing permission to share. Results in Radix while asking the user to select a persona to log into this DApp. Okay, I really like this idea of persona. I mean, no one else really has it, but basically it lets me segment my stuff really easily, and I'm a fan of that, truthfully. Can't tell you like how many accounts I've set up for other people, and it's like just managing both of their accounts is a little bit annoying. But having a persona that has specific rules regarding the usage of funds with an account, like I'm a fan. I like that. This proof comes in the form of a signed challenge against an on-ledger identity component. For each persona a user creates in the Radix wallet, the wallet automatically creates an associated on-ledger identity, which contains none of the personal data held in the wallet. Important. Very important. This identity includes a public key in its metadata, and the signature of the challenge uses the corresponding private key. ROLA, Radix off-ledger authentication, may be used in your DApp backend to check if the login challenge is correct against on-ledger state. Okay, I mean, that makes perfect sense. Like, basically, this is very similar to Ethereum sign-on. that is used in multiple apps like Kitty. There's a cat D app that you log into by signing a challenge, and it says that an Ethereum wallet when you sign in. Wallet Connect also implements something very, very similar to this. So I just realized that like you haven't been able to see literally anything that I've been doing. I'm such a chump. I'm just reading it off to you. Oof. Oh, that's hilarious. Well, I hope you've enjoyed it anyways, huh? I've taken all these notes. Boom, notes. And here we are. We're almost done with our Wallet Connector API. Alright. So we can use a persona. They log in perhaps for a given active session. You may specify an entity address directly without requesting a login from the wallet. Alright, so we can log in with challenge, and the challenge is this. Boom. Send a transaction. Your DApp can send transactions to the user's Radix wallet for them to review, sign, and submit them to the Radix network. Okay, so the wallet does submit things to the Radix network. So I guess what's the gateway API for? Maybe just to query information from the network? I could see that. It's important to note that your DApp sends to the Radix wallet is actually a transaction manifest stub. It is completed before submission by the Radix wallet. Add a command to lock the necessary amount of network fees from one of the user's accounts. It may also assert commands to the manifest according to the user desires. For expected returns. Provided. Okay. Conforming transaction manifest format. Okay, good to know. It will be there soon, they say. Okay, but we can build manifest. We got our manifest builder. We call methods on components, withdraw by amount, take from worktop. Okay, we know what worktops are. Resource, XRD bucket. I guess that's the identifier. I don't know, but we call a method. We can call methods. We pass in the bucket XRD bucket. Okay, so this. Oh, okay. So this creates. I would assume that this creates a bucket called XRD bucket, and we can pass that bucket into another method, and then we can call a method. And I guess this expression says we're done. So we call method on a specific component. We deposit batch. We build. We turn it into a string. Oh. More examples can be found here. Yes, please. I would love more examples. Alright, that doesn't exist. There are no pull requests. There are no issues. It was updated 2 weeks ago. Okay, send transaction. It will be completed, presented to the user for review, signed as required, and submitted to the Radix network to be processed. So the Radix wallet does everything for you. The DApp doesn't need to care about anything. So I guess in that triangle I was talking about, we have the DApp, we have the wallet communicates with Ledger. Perfect. So we need a transaction manifest, we need a version. We need to specify the version of the transaction manifest. That's interesting. Used for deploying packages. Okay. Message be included in the transaction. Okay. Rejected, missing extension, canceled by, wallet request validation, wallet response validation, wrong network. Failed to prepare, failed to compile, failed to sign, failed to submit, failed to pull, submitted transaction. Was duplicate. So I guess that's why you need the version. Has failed transaction status. App submitted a transaction to gateway and pulled transaction status telling app it was a failed transaction. Okay. Okay. Okay, so I guess the DApps requested it. Alright, let's go back to... Says our wallet SDK, what's our gateway SDK? What do you do? Simple way of querying state on the Radix network. Okay, that's what I thought. So the gateway SDK is used to get crap from the ledger so we can make decisions. The wallet is used to send crap to the ledger so we can make actions. So we can perform actions. And yeah, that's perfectly fine with me. I like that. So now we have a pretty good comprehension of our Radix gateway. And we also have a pretty good comprehension of the wallet connector API. Specifically, our... what is it? Wallet SDK and the Radix DApp Toolkit, I guess, combines both of those things, which is nice. Radix Engine Toolkit, what are you? It's a multi-platform library written in Rust that exposes a set of functions to help clients written in languages other than Rust compile and decompile transactions. Perform SBOR. SBOR. Serialized binary encoding and decoding, derive virtual account and virtual badge addresses and other functionalities. Okay, that's good. That's nice. How important is that? I guess I would expect this Radix DApp Toolkit to have that in there, but the fact that it's written in Rust, like, I'm a fan. I like that. So I can compile Rust down into binaries that I can run anywhere, and I do like that. So, okay. Rolla, Radix offline off-ledger authentication. Authenticating a user's login using a persona. Authenticating users' control of an account on Radix. By Rolla, authenticating a cryptographic proof of control of an entity on the Radix network. Yeah, that makes sense. An identity of an account. So personas use identity components. Accounts use account components. Network to enable cycling of public keys used for authentication rather than relying on fixed. Oh, they cycle. Okay. Components on Radix network include a piece of metadata that defines the public keys as the owner key for that component, corresponding to the private key that created the component. Okay. Creates a challenge with a limited time of validity and passes it to the front end. The dApp front end makes a request to the Radix wallet for either a login or account addresses with required proof of ownership. The challenge is included in this request. Okay. Selects the persona accounts requested. The user's Radix wallet produce a cryptographic signature using the private key corresponding to the public key set as the account/identity's current owner key, public key. It returns to the dApp the address, challenge, public key, and signature. That information to Rolla in the dApp backend. That the address, public key, and signature match for the current state of the account/identity component. If so, correct proof has been provided, and the dApp backend and frontend may act accordingly. Okay. So I guess you put Rolla into your backend. I don't really know how that works. Okay. That's my guess. Interesting that... I mean, it makes sense. It's easy enough to validate the private key and a signature and a hash and all that good stuff. So, okay. So we have a comprehension of our wallet SDK, our gateway SDK, our Radix gateway just in general, wallet connector API. I'm satisfied. We did not get to how to write tests, but we do know how to read data from the ledger, so we took a look at those two things as well. Also, I'm super sorry that I guess I didn't have like my face in the bottom right corner of the screen. It was just my face the entire time, so I apologize. Hopefully everything I was saying was still making sense. I was basically just pointing at things on my screen and reading them out and then giving descriptions of them, so shouldn't have been that horrible. But still, definitely something I can improve. And I also have some questions that I'm going to ask. And next week we are going to dive into how to fetch rewrite tests. Because I've learned that some of the things that I was trying to do in Radix, like with the vault inside of a struct, for example, does not work. Doesn't work at all. So, lessons learned, right? But I need to be able to test this stuff to make sure that it actually does work. But there we go. Thank you so much for watching, chumps. I really appreciate it. It's a lot of fun to learn this stuff and to describe it and just like externalize everything that I'm trying to do. And I hope that everything I described is also useful to you. That mental model of the triangle, absolutely game-changing as far as anyone building a DApp. You need to have a comprehension of those three pieces or you can't build your DApp. Doesn't matter. You literally can't. So that's probably my foundational piece of everything that I look at. I'm probably going to take a look at, put together a nice simple list of principles that I'm aware of in smart contract development and start learning those in Radix. I kind of already did that a couple of weeks ago, so yeah, I already did that. So we're good to go. After next week, after I'm able to test crap, we can start writing smart contracts. That's cool. Thank you so much for joining. Have an awesome Wednesday.